Okay, so today we're going to be talking about cycling of matter through the environment. And in your notes, you're going to fill in a couple of words, but mostly you're going to be filling in the words on the picture. Okay, so we're going to start with the hydraulic cycle or hydraulic cycle or water cycle, which is easier. All right, and this should really be a review from like 7th grade. So basically precipitation is anything that falls from the sky. So this is rain, snow, etc. And it is going to run down the mountain. It's going to end up in the ocean, or it's going to end up as seepage or groundwater. So it's going to either sink into the ground and become seepage or groundwater, or it's going to be stored in an ocean or a lake, or it's going to be used by plants. These are the three options once the rain goes down onto the earth, right? So if it's in a water, if it's stored in the ocean or a lake, it is going to evaporate, okay? Now, what we call transpiration is basically plant sweating. So like when we sweat, we get water on our skin that evaporates. But when plants release water out onto their leaves, that is called transpiration. Okay, so the water is released as vapor. Evaporation is vapor. That vapor condenses into a liquid and then rains. Okay, so that is the water cycle, and that should be a review from 7th grade. All right, biogeochemical cycle is the movement of a chemical through the biological and geological parts. In other words, for the living parts and the non-living parts. Okay, so oxygen cycle also should be a review because it's very easy. We have photosynthesis. Photosynthesis releases oxygen in the environment. We breathe in the oxygen. Also, by the way, plants, we could draw a line here. So we breathe in the oxygen. Plants also are going to take in some oxygen, right? Because they also do cellular respiration. That's important to remember. And we breathe out carbon dioxide. They don't, right? They don't breathe out carbon dioxide. But we do. We breathe out carbon dioxide, and that carbon dioxide is used in photosynthesis, which releases oxygen. So this is the easiest cycle there is. Carbon, this is a little more complicated. This is the building block of life. We know carbon moves through carbon from the atmosphere through the food web and then returns to the atmosphere. We also, this is a human impact right here. Human, we're going to talk more about human impacts later, but this is a human impact. When we burn fossil fuels, because coal is basically just carbon, okay? So when we burn the coal, the carbon, the oil, the gas, all of that releases carbon into the atmosphere, okay? So some carbon is stored for a long period of time, like coal is stored carbon. That's been there a long time. And we call those carbon sinks. Okay, so here's your carbon cycle. And as you can see, it's a little more in depth. Okay, so let's start here with the carbon dioxide in the air. So there's carbon dioxide in the air because we breathe it out. Plants breathe it out, right? So it's in the air. When organisms decompose, that is then also releasing some carbon into the air. And then combustion, this is our fossil fuels right here. Those are all ways in which we get carbon dioxide in the air. Photosynthesis even happens, respiration even happens in the water. So things in the water are respiring and oxygen is being released into the water, or carbon is being released into the water, all right? And we have carbon dioxide dissolved in the water. So that's how we get it in the atmosphere. That's how we get it out there. What uses it? What uses that carbon? Photosynthesis in the land and photosynthesis on the water. In fact, more water photosynthesis than anything. That's basically all that uses the carbon, okay? So the carbon is being released Fossil fuels hold the carbon. This is a sink. Why is my pen sink? Okay, so fossil fuels are a sink. They hold on to carbon dioxide. So is the carbon dioxide that gets dissolved in water. That's also considered a sink. Okay, so they're holding on to carbon for a long period of time. But when we burn fossil fuels, we release that. When we breathe, we release that. Okay, when all the animals and all the organisms undergo cellular respiration, we release carbon dioxide. So photosynthesis is the only process as of yet that is pulling the carbon out of the atmosphere. And that is why having plants is so important. Nitrogen cycles. So this one's a little hard because we have to talk about nitrogen fixing bacteria. So most of the nitrogen cycle takes place underground. So some bacteria convert gas nitrogen to ammonia. Okay, so gas nitrogen to ammonia is called nitrogen fixation. Okay, now some of these nitrogen fixing bacteria are going to live on roots. They're going to live in the soil. Okay, so either way, these little bacteria are going to take the nitrogen gas that's just naturally found in the atmosphere and convert that to ammonia, okay? When decomposers decompose things, that nitrogen also turns into ammonia. And that's called ammonification, but that's not important to me. All right, now we have nitrifying bacteria. So they are going to turn the ammonia into nitrites. Okay, and nitrites can be used by plants and be released into the atmosphere. So ammonia released into the soil is transformed into ammonium and then ammonium to nitrate. So I don't care that you know this step. The nitrifying bacteria, so we had nitrogen fixing makes ammonia, nitrifying makes nitrate. And then that nitrate is what can move through the food chain. Okay, ammonia can't move through the nitrogen, it can't move through the food web. It can't do any of that. Okay, so once the nitrogen in the atmosphere, it can't be used by anything. So it has to be fixed to be able to be used. So we fix it by turning it into ammonia. Then we have nitrifying bacteria that turns it into nitrites. And then it can go back out into the atmosphere. Animals are going to eat the nitrogen through plants, and plants get it through their roots because there's bacteria in the soil. Okay, they love this question on the EOC, so just know nitrifying turns it into nitrates, nitrogen fixing turns it into ammonia. And ammonium is like the same thing that you clean your house with, okay, ammonia. All right, the phosphorus cycle takes place above and below ground. It starts off in a geologic way because phosphate is carried through the erosion of rocks, okay? So here we have rain. Rain comes down, erodes through here, weathering of the rocks. So the rocks are weathered, and the phosphorus is going to leak into the water. It's going to be leaked into the soil, okay? And as the soil is decomposed by the water, it is going to release the phosphate. Now, here's the thing. The important thing about the phosphorus cycle is, number one, it starts with releasing the phosphate from the rocks and the sediments in the ground soil, okay? We, as human beings, we make this worse because fertilizer has a ton of phosphorus in it. And when we put all this fertilizer and growth minerals on the plants, that gets into the soil. And then we end up with so much phosphate in any given solution, so any area near agriculture is going to end up with an overabundance of phosphate, which can create all kinds of an overabundance of nutrients, which can create eutrophication in a lake. So we don't want that. Mining does the same thing, because remember, we get the phosphorus from weathering the rocks, right? Like having it rain and getting the phosphorus out of the rocks. Well, in mining, we're basically chopping up all of those rocks. So that phosphorus is going to leach into the soil in amazingly high rates.